Okay, let me go through a two-way ANOVA that does not have an interaction effect. And let's take a look at that interaction effect visually also. So here what I did, somewhat of a nonsense thing, I guess. My outcome variable was just age. So I was using the Pennsylvania Behavioral Risk Factor Surveillance Survey again, like we did in the focus task. And just looking at, were there differences in age of the participants based on sex, like male, female, and whether or not they were blind? So a 1 would be, on the blind variable would be, yes, they are blind or have a very hard time seeing, and 2 would be no, that they are not blind. So looking at these this output here, the first thing I would go to would be this interaction term. So that would be the one that has the asterisk in it. And that's to answer the question, does it matter which sex? If we want to know whether there was a difference in blindness, a difference in age of the blind participants and the participants who weren't blind, does it matter which sex we're talking about? Is there a difference between the male blind non-blind and the female blind non-blind? And here, if this would be below 0.05, we would say yes, it looks like it does matter. So we're going to have to go into that in a little more depth. In our case, we're well above 0.05, so we would say there isn't a significant interaction effect, is the way we would say that. In other words, we can reasonably look for whether there was a difference in age between the two sexes overall, and a difference in age between blind and non-blind participants. We don't have to worry about them tangling up together, or interacting is the common word there. And before I interpret those main effects, let's take a look at the descriptives, what we have going on here. So again, 1 on the blind variable means that the person reported being blind or extremely difficult time seeing. So that would be these right here. And 2 would be the participants who were not blind. Notice this doesn't tell you how many were in each group. You'd have to pull up the descriptive chart to do that, but we're not going to worry about that for right now. What I do want to also point out is that sex, 1 is male here, 2 is female. So these 2 points here represent the 2 males. These are both male groups, and these darker dots here represent the females. So we really have 4 subgroups represented here, and we get that because the sex variable had 2 factors, male, female, and blind had 2 factors, blind or not blind. So 2 times 2 should give us 4 dots. If, for example, the blind had 3 categories, maybe completely blind, visually impaired, like somewhat visually impaired, and no visual impairments, then we would have 6 different subgroups. We'd have 2 here times 3 here. So that's going to tell us how many subgroups we have. Keep in mind, it helps me to remember that each of these dots represents a group of people. So for example, this white dot right here would be the males who are not blind. And the height of that dot is going to tell you what age there is. So it looks like the average age of the non-blind males in this study were 50. It was around 50. Whereas the average age of the non-blind females was a little bit higher, maybe 52-ish, 53. Both of the groups who reported being blind or extreme visual impairments, both the males and the females were similar to 60, somewhere around 60. So you notice that it does depend a little bit whether we're talking about males, or sorry, whether we're talking about the group that reported being blind and the group that didn't report being blind when we say, is there a difference in male females? Because here, for the group that reported being blind, we would say, there's probably not much of a difference. We'd want to look at the statistics to be sure, but probably not too much of a difference. Whereas here, we might say, there's a little more chance of a difference. And yet, when we say it depends, that is true, and we can see that it does depend a little bit, but when you really start to see this interaction term be significant is when these two lines cross. So you might have this dark dot down here, and when you connect it, the two lines actually cross. That's typically what we would see visually from an interaction, is that the different descriptive lines here would be crossing, or at least at a radically different slope. So maybe if this black dot was way up here, and so this slope was right here, and this slope was completely different slope, that would also suggest a potential interaction. And to see if it's big enough to be significant, we would double check this p-value here. But in our case, the closer they are to parallel, the closer p is going to be to 1. And if it's parallel enough, like we have here, it's not a significant interaction effect. So once we've determined that there's not a significant interaction, we can go to what are called the main effects. There's where we can see, is there a difference in average age between males and females? And that p-value is not giving us statistical significance. So we don't have a statistically significant difference between males and females in the age category. Although, again, if you look closely in our sample here, we can see in both cases, whether you're in the blind or the non-blind, the female group was higher. That's just in the sample. It's not convincing enough to tell us that it's in the population. That's not a significant difference. However, for the blind and non-blind, between those two groups, there is a significant difference in average age. We're seeing that come in as below 0.05. Whether or not we correct it for Bonferroni or not here, it's still going to be statistically significant, because these groups, when you combine them together, when you don't differentiate by sex, kind of take the middle value there, the average age of the blind participants in the study was around 60, whereas if you think about roughly in between these two, the average age of the participants who didn't report being blind was closer to 50, and that's a pretty big difference there in the sample. We might want to see some nice confidence intervals to see whether that was a practically significant difference, but it certainly was a statistically significant difference. So how do we sum all of this up in a single sentence? We might say something like, regardless of whether the participants were male or female, the participants who reported being blind were significantly older than the ones who were not blind.